Dear students, welcome to a new video for report writing skills subject. Now, we will continue the hypothesis testing, and here is the steps for the hypothesis testing. The first step is state the hypothesis and identify the claim. This is the first step in the hypothesis testing, and we already in the previous video mentioned how to set any hypothesis, and also mentioned that we have two main hypotheses, which are H node, which is the null hypothesis, and H1, which is the alternative hypothesis. And we have a situation, and we have a signs greater than, less than, and equal and not equal signs, and we put the null hypothesis and the alternative hypothesis according to our problem or our situation. And when we identify the claim and set the H node and the H1, we already finished the first step, which is the main point and main step, which is depending on it all the other steps. Step number 2, which is finding the critical values from the appropriate table in the appendix. We have already also mentioned to the critical value definition and the critical and non-critical regions, and how to determine the critical region from the tables. Also, we have many tables in the appendixes or tables, statistical tables in many references. Which are Z table, T table, chi-square table, and so on, F table, and many other tables. Each test have a table suitable for it, and appropriate tables in each situations is defined according to our problem and our population and sample size. Here, we in this step we have a critical value that is obtained from the table, and its value maybe some references called it a tabulated table, a tabulated value, because we got it from the table. The critical value or the tabulated value is be compared to the test value in third step. We compute the test value according to our tests. Also, in the previous video, we defined the statistical test and the test value definition that's obtained according to the test that we are interested in. If you use that test, we substitute our values in the Z test equation. And if we use t-test or the proportional test or a non-parametric test, each test has its rule and its formula, and we substitute the values given in the problem and in the situation in the test rule. So we compute in this step 3 the value which is calculated. Here it's value calculated from the test value. Now we have a value calculated in the step 3 and the value tabulated from the table in the appendixes, and we will compare this calculated value with the tabulated value. I mean that we compare the test value with the critical value. Then in step 4, we make a decision about the results, our situation, to reject or not reject the null hypothesis depending on this comparison for each suitable situation. And finally, we will summarize the results and get the report. Here, the meaning of report is coming clearer to be our report about the hypothesis testing. Note that you are in a situation that not all you deal with are knowing more about the hypothesis testing. So you should summarize your results with a very good and clear report, not full of statistical techniques and statistical analysis, because you may get contact with another person who are not involving in a statistical techniques. So make a report and summarize the results with a more clear point and not in a statistical depth. Here we have a z-test for a mean. If our formula or z value getted by our test value when using that test is equal to the observed value minus the expected value over the standard error. Note that the standard error is the square root for the variance. The z-test is a statistical test for the mean of the population, and it also can be used when the sample size m small is greater than or equal to 30, or when the population is normally distributed and sigma is known. Sigma, which is the root for sigma square with the variance for the population. So the standard error, if we know the standard error and the population is normally distributed and the sample size is greater than is equal to 30, we can easily use the z-test to get the test value and take the hypothesis steps, test steps. Here we can substitute in this formula that z equal to x bar, which is the sample mean, minus x bar minus mu, which is the hypothesis population mean, sigma, which is the population standard deviation, and the sample size, root over root m. For the z-test, the observed value is the value of the sample. Here is the observed value is the value of the sample. We get this value from the sample and sample mean. And the expected value is the value of the population mean. So here we get the value of the okay, here is the expected value is the value of from the population mean. So we already get the difference between the sample mean and the population mean in the denominator, and in the denominator we have the population standard deviation over the root of the sample size, assuming that the null hypothesis is true. So this is me. We apply this rule to get step 3. Now we are ready to get the test hypothesis steps. Step 1 is the H node, determine H node and H1, and step 2, give the critical value appropriate with from the tables, and this is the from table the calculated value, tabulated value, and here we are step 3, getting the test value by using this formula, which is the difference between the sample mean and the population mean over the standard error over the root m. So we are ready for any situation. For example, professors' salaries. Researchers report that the average salary of the assistant professor is more than $42,000. A sample of 30 assistant professors has a mean salary of $43,260, and with alpha, which is the level of significance, test the claim the assistant professor earned more than $42,000 per year. The standard deviation of the population is $5,230. Now we will apply the rules of a statistical test as we mentioned before. The first step is to state the hypothesis and identify the claim. Note that in the hypothesis or in this situation, he said that the mu and the mean of the salary per year is $42,000, and the alternative says more than. This thought we have a greater than sign because we already see the word more than, which is a key word for a greater than sign. And this is our claim that it earned more than $42,000 per year. Now it is a very important step to state the hypothesis, and you may be asked in this situation about what is the alternative hypothesis it is one tail test or not, it is a left tail or right tail. Of course, you know these answers from the previous video, because we said that if you have a greater than sign, this means you have a right tail tilde, which is one tail test. Okay, and here the claim is H1 because we claim the greater than, and H node is if the mean is equal and a certain number. Let's move now to step 2, which is finding the critical value when we have a level of significance 0.05 in and it's the right tilde test because it's greater than sign, and we get it from that table, and we will find that z equal to 1.65. Now we will compute the in the step 3 compute the test value by using the Z formula that mentioned in the previous slide. Here, the X bar, which is the population obtained from the mean obtained from the sample, or the sample mean. The sample mean X bar was 43,260 as given in the problem, and the population mean is $42,000 as also given in the problem, and also it's given that sigma equal to 5,230, which is the standard error or standard deviation over the root n, which is 30. Here let's note that we have n equal 30, which is suitable with that test. Also it's normally distributed, so we use the Z formula or use the Z test. Step number 4, make your decision. Now we will compare two main values, which are the value obtained from the table, the critical value or the value tabulated, with the value calculated, which is obtained from our formula or the test value. When we compare the critical value with the test value, we found that the tabulated value, critical value, is larger than the test value. So it's not critical, not in the critical region, so the decision is not to reject the null hypothesis. Now we decide not to reject the null hypothesis. If you can't compare or can't get your decision according to this comparison, you can easily draw this and know the answer. Here we have a normally distributed, and here is the point. The critical value from Z table is 1.65 here. So here this point 1.65 here. So this is the critical value. The critical value is here. Get all the place or under the curve, all the region under the curve into two regions. This is the rejected region and this is the accepted region. I mean any values in this region, which is the green region here, that's green, any value in the green region will be accepted and don't reject the null hypothesis if the value here, and if the value here in the red region, we will here until the point of the critical value we will reject. So let's go to the value of the test computed from the formula. It's a 1.32, which is here 1.32, here 1, for example, here 1.32, here 1.32. So it's in the green or the accepted region, which is non-critical region. So the decision is not rejected the null hypothesis. It's very easy when you draw your diagram to know the value very well. Here it's our shape, but more clearly from the normal curve, and we have here points of the critical value, and this is from the table, obtained from the table, and here it's the test value, which is obtained from the Z formula, here from Z table. When you draw the curve and normal curve and zero in here in the original points, and the values and the curve is getted two parts. The part is the rejected value, and this part is not rejected or the accepting region. So our test value, okay, 1.32 here in the accepted region, so we will not reject the null hypothesis, and we will summarize our result. There is not enough evidence to support the claim that the assistant professors earn more than than this value per year, and this is maybe a report for your manager that you get it over a hypothesis testing technique. Another example, costs of men's athletes' shoes. A researcher claims that the average cost of the men's athletes' shoes is less than, note that the key words, less than $80. He selects a random sample of 36 pairs of shoes from a catalog, and he finds that the following costs, the costs have been rounded to the nearest dollar. Is there any evidence to support the researcher's claim at level of significance or alpha equal to 0.1? I mean, it's 10%. Assume that sigma equal to 19.2. Here we have values, but we haven't the mean direct. We have the certain values of the sample, and with a 36 value, and we ought to calculate the mean by using the mean rule, which is the summation of all values over 36. So we have here 36 value, and step 1 we will state the hypothesis. Like any step in the hypothesis testing, we will get each node is equal exactly $80, and our claim is the athlete shoes is less than 80 from the problem situation, and words we translate it into a time. So we have a test with a left-tailed test, and one-tailed test. So we use the appropriate table, which is the Z table, to get the critical value. And we find the critical value at a level of significance 10% is equal to negative 1.28. Note that when you have a left-tailed test, when you have a left-tailed test, the value of U is negative. The value of the test will be with a negative sign. So concentrate when you use this value to compare with a negative sign to get your decision more appropriate to the test. Now we already have a critical value here, and we want to compute the tested value to compare the tested value with the critical value. But we know the mu value, which is the mean from the population, but we don't know the mean from the sample. How to calculate it? It's very simple to calculate the mean obtained from the sample. X bar equal to summation of x over n from I equal 1 up to 36. Now we will sum all these given data and divide it by 36 to get x bar, which is equal to 75. And we have also given a sigma, which is the square root for the variance, equal to 19.2 and n equal to 36. So we will substitute in the z formula that here in the numerator the difference between 75 and 80, and in the denominator we have sigma over root n, and the value is equal to minus 1.56. Here, if you draw the values, we will draw a normal curve, and we make a decision that by comparing the test value, which is negative 1.56, by the critical value, which was negative 1.28. Let's show it in the graph. It's more clearly. Here it is the critical value. Here it separates the value under the curve with two main values. The green points, which is accepted area or accepted region, which is non-critical region, and another area which is rejected here, which is in the left. So it's a left tail test, and the critical value separates the regions into two regions. This is the acceptance regions, which is a non-critical region. Here any points here is accepted, and here it is the rejected region or critical region. So we will move now to our value of the test value, which is equal to negative 1.56. It's here in the rejected region. So our decision is to reject the null hypothesis. Here is to reject the null hypothesis. And our step 5 is summarizing the result that there is enough evidence to support the claim that the average cost of the men's athletes' shoes is less than $80. Now let's move to the third example, which is the cost of rehabilitations. The Medical Rehabilitations Education Foundation reports that the average cost of rehabilitations for stroke victims is $24,672. To see if the average cost of rehabilitations is different in a particular hospital, a researcher selects a random sample of 35 stroke victims in the hospital and finds that the average cost of there is $25,226. The standard deviation of the population is 3,251. At level of significance alpha equal to 0.01, can be concluded that the average cost is at a particular hospital is different from this value. Note that here in this situation, no mention for greater than or less than. He just want to know is there a difference from. So we are in a situation with not an equal sign. I mean, we have the alternative hypothesis with two tail tests and will be not equal signs. So you should read the situation very much to be sure what is the null hypothesis and the alternative hypothesis, because this is the most important step at the first step, which is stating the hypothesis and identifying the claim. Our claim here is H1, where mu not equal to this certain value, but the null hypothesis is mu equal to this value. Now we will get the critical values from Z table, and alpha equal to 0.01, which is the level of significance. Note that the test is two-tailed test because we have not equal signs in H1, and the critical values from that table is minus 2.58 and plus 2.58. Let's move to the third step, which is computing the test values. We already have in this situation the population mean and the sample mean and sigma and n. So we will substituting in z formula to get z equal to 1.01. Now we will draw our curve and normal curve to determine the rejected region and the accepted region and make our decision about our chart depending on this normal curve. Make the decision that we don't reject the null hypothesis since the test falls in the critical region. Let's see our normal curve here, and we have a critical value from the test here. It's let's take it with the red here. Here it's rejected region. It's a rejected region. Here it is rejected. We will reject here, and we will reject here if the value from the test here in this space or here we will reject the null hypothesis. But if it's here in the acceptance space, we will which is known by the accepted region or the non-critical region, we will here accept the null hypothesis or don't reject the null hypothesis. So here, if we call again the test value, we found it's equal to 1.0 point, which is here in the accepted region or non-critical region. So when summarizing our result, there is not enough evidence to support the claim that the average cost of the rehabilitations at a particular hospital is different from $24,672. Now you get the three cases if you have a right tail test, and the second is the left tail test, and finally an example for a two tail test. Please concentrate in the three types. You may faced with any problem of the three types. Be ready for this situation and the problem and translate words very well. You may be asked about the null hypothesis, the alternative hypothesis, the type of the test, the critical test value given, and they may ask it about the value of the test value and your decision is reject null hypothesis or not reject null hypothesis. Also be careful, translate, summarize the results very well, because this is the main idea of our subject, is to get a good report and a right report in a professional way. Thank you for listening. This was our part for the hypothesis testing. Thank you.